All right, hi, welcome back. Um, we're going to get stuck into, more lectures. In particular, we're getting on to 1.2 now, which is our introduction to Git. Before we get into that, there's been some questions on the chat throughout the break that I want to address. So, the kind of questions are just around like how do I get set up locally and whatnot. One thing I would strongly like, unless you're really confident about everything, I would strongly recommend that people try and do, just even the first week through VLab or something like that. I have a really bad internet connection here. I have, some 4G modem with like a 2 megabit upload speed. Like the quality you're seeing right here is the best I can do at this stupid place. So, um, it's like unless you're kind of overseas, you're probably going to be okay using VLab for a week. And the reason I encourage you to use it is because it will help you get familiar with the content very quickly without getting bogged down in the setup. You're going to have to test some stuff on VLab anyway in your exam for the project and everything else. So you're going to have to be familiar with it. And also, once you are kind of just generally using it, you'll be familiar with what to expect locally. I don't know. I would do this week on VLab just to get settled. And then just if you want to set things up locally, feel free to. What we're getting into now, though, is one of three lectures on Git. We do two big ones early on because it's really important to get this right early because it's easier to understand Git and teach yourself. It's easier for us to explain Git and you learn a little bit of Python than it is for us to teach Python and learn a little bit of Git, even though we're doing Python tomorrow. This first lecture on Git, though, is all about using Git by yourself, which isn't how you use it in the course, but this is a good place to start. So, the problem that we face, that we're looking for a solution for, think about requirements analysis again. This is what I mean. Everything in life starts with the problem. Everything in life starts with what you're trying to solve, and this is an example. Like, to effectively work on large projects in groups of engineers, we need a more complex method of managing our code than just emailing stuff around or however the hell else you might do it. And the two things we need, the two requirements we need to solve this problem are it needs to have some semblance of version control, as in it kind of keeps track of a history, like a detailed log of everything that's happened. And we need some ability to concurrently program. We need an ability for multiple people to work on the same code without it kind of clashing. So, if you tried to use Dropbox to share code, that's all well and good if one of you does all the work, stops, uploads it, the other one downloads it, does all the work. You know what I mean? Like, it's not multi-threaded, it's not parallel. You can just like take turns in doing it. So we need some way to deal with this concurrency of people working on a project rather than just one at a time. So classic cloud storage does allow multiple people to share things, and it also has version control. And it's like, great, that's good, but it's very high level. We need something more specific for programmers. Joshua has said in the chat, which I love, that given Google Docs vibes. Yeah, totally. I might add that into the slides. That's a great point. I was kind of hitting myself thinking of analogies the other day, but it's exactly like Google Docs or Google Sheets, right? Like Google Sheets, Google Docs, it allows you to work on the same thing at the same time. Obviously, if you both try and edit the same cell or the same word at the exact same time, everything explodes, but that's just unpreventable. And it also keeps track of a history, right? So we're trying to solve these problems, but in a programming landscape, because things like Dropbox, Google Docs, whatever, these all are really just ways of solving it for like general things, not for programmers. The way we solve this problem is by using Git. Git is a version control tool that enables people to work concurrently on the same code base. It's built for programmers. It's designed for managing code across lots of people with a detailed history. Super, super powerful. There are other solutions to the same problem, like SVN and stuff, but Git continues to be popular, and I think it's growing in popularity from what I can tell, and in the open source community. It's probably, as far as I can tell, it's the most popular form of version control software out there, Git. We get, like, okay, so Git's like a thing, but how do we actually use it? Oh, sorry, one slide, I jumped ahead. When we say that Git is like a version control software, it's really easy to think of it like, you just push some stuff up to the cloud, and then you pull it back down. One thing that Git is, though, is GitHub is a distributed version control software. And what that means is that everyone has a copy of everything, or at least can have a copy of everything. So whilst there is always a central cloud point, so if you and me and Dev and Joshua are all working on a project, we're all like 4 of us kind of communicating via a cloud, right? So it's like it's always via this like server somewhere, but we all have copies and a full backup of all the work. That's just how it is by design. So it's a totally distributed approach, which is very useful for redundancy and whatnot. In terms of the tools that we use for Git, Git is just a programming language. It's just a standard, I had an example in my head earlier, but I lost it again. It's like Git's just a language. By itself, it's just a way to describe how to make something work, right? Just like how C is a language and GCC is a compiler, a way to use it. But with Git, we actually use specific tools to interact with it. So there are certain pieces of software out there that implement the Git language to allow you to interact with it, and many of them implement it as an interactive, easy-to-use web app. The 3 most popular ones are GitHub, Bitbucket, and GitLab. GitHub is previously, it might have been open source, I'm not sure. Microsoft bought it years ago. So GitHub's kind of run by Microsoft. It's definitely the biggest one. Bitbucket's run by our local Atlassian friends, UNSW founder kind of company. Bitbucket's a little less popular. I think it's not quite getting the same kind of attention as GitHub these days. So I think GitHub is growing pretty rapidly in popularity. I mainly work with Bitbucket, for example. And then we have GitLab, which is essentially like you can go and host your own GitLab. It's kind of like the free, fun, open source version of it. And CSE actually has their own version of this. So github.com, which is like all great and fine, it's still like just all on github.com, whereas GitLab, you can go and host your own. So for instance, if you go to GitLab, if you Google GitLab, you can actually go to gitlab.com, which is like GitLab's site, where you can use Git there if you want to. But for CSE, we actually have our own, GitLab instance. So basically, we have our own internal CSE Git website, gitlab.cse.unsw.edu.au, like that. So yeah, we're using GitLab for the course. Now, in terms of learning Git, we're going to learn it in 3 key stages. We're going to do the first and second one today. We're going to learn about Git on a single machine, just you. We're going to learn about Git on multiple machines, where it's just you. And then next week, we're going to learn about Git when you're dealing with it across a team of engineers. So many people working on the same thing. So we just kind of do it in that kind of progressive way. We have not produced content on like a step-by-step guide on everything Git. The main reason for that is because we'd spend a lot of time that we could otherwise spend helping you out throughout the term, developing content that frankly is just extremely well developed already by other people. So Atlassian, for instance, has an extremely detailed, useful Git resource where they take you through everything. They have little diagrams and instructions. They obviously are showing you how to set things up with Bitbucket and whatnot, but this is all set up, but they have these nice little diagrams that take you through things and give extensive detail. So we're going to take a very practical approach and talk through it. Though if you really want to dig into the weeds and learn a little bit more about the background of things, there's tons of resources online, and I'd probably recommend starting with Atlassian's Guide to Git. The first stage, and hopefully things will start to make sense once we go through some examples, is we want to set up Git on set up and work with a Git repo on a single machine. Now, for the sake of, so let's do this one on VLab. So what I'm going to do is I'm going to open Tiger VNC, which is how I connect to VLab. I hope this doesn't hurt the internet. See how it goes. So I'm going to log into VLab. You can do this locally. You can log into VLab too. And one of the first things I'm going to do is I'm just going to really, really quickly do one of the first steps in the the lab, because I think that this is the step people tend to miss out on. Let me just get rid of these for a sec. Don't worry about what I'm doing right now. I'm just trying to reset something so we can start again. So, okay, so when you use VLab or your own machine, if you haven't done this stuff before, to get set up with Git, the only real simple thing you have to do is you write ssh-keygen on the terminal, you hit enter, and then it's going to ask you a few questions, and you can just hit enter, and you can hit enter, and you can hit enter. You can just keep clicking enter, and then it'll crap out this thing, and you'll be like, what is that artwork? You know? And you'll be like, all right, I'm a little scared now. The next thing you do is you want to get what we call your SSH public key. What this is, it's this magical string of characters that is a way of identifying you so that you can get access to your GitLab without needing to enter a password all the time. Think of it like a password that's stored, but without getting into the cybersecurity background. It's a fancy password where other people can get it, but they can't access it. So it's like a password you can share. Go read into private key, public key stuff if you want to. To get this particular string, all you have to do is type in cat :tilde. Again, this is all in the lab instructions. I'm not telling you anything that isn't written down in a lot more detail. It's just people always miss this, so we're starting to show them more. I want to print out this file, and there's my giant string. And what I'm going to do is I'm literally going to go take that giant string, I'm going to copy it, I'm going to go to my web browser. It can be in VLab, it can be on your own machine. I'm going to go up to the top right, I'm going to go to settings on my profile, I'm going to go to SSH keys. I'm aware this is recorded, so I'm rushing through it because I know you can just pause it. And then what I'm going to do is I'm going to go here and I'm literally just going to paste this in and click add key. That's that whole step done. You follow that exact process. There's very little ambiguity or room to fall off the wagon in that process. And now we're all set up on VLab. If I want to do that locally now, because I have my own local machine, I'll do the same thing. So I'm going to open up my terminal on Windows. This is a Linux terminal. Again, this is that Windows subsystem thing I mentioned. I'm going to go to my .ssh folder. Let me make this a little bit bigger because I think with the internet connection, it might not be perfect. Well, that's a bit large. Yeah, that'll do. So I'm going to go to this folder. I'm going to do the exact same thing again. SSH keygen. Enter, enter, enter. I get my funny artwork. I cat SSH ID RSA whatever. I go and take this. I copy and I go back to SSH keys and I paste it in here. And then we're all good. So what I've done now is I've set up my local machine and I've set up VLab. You only have to set up one, but you can set up both. You can set up three. You can set up your laptop and your desktop and your other laptop and VLab and whatever the hell else you want, right? But the point is you have to do this for every system you want to work on. You should do this on every system you want to work with Git on. So that's the first part, the SSH keys. The next thing we're going to do is we're actually going to try and clone a repository from Git to work on it locally. So what I'm going to do is I'm going to go and create my own repository just for this lecture. In fact, I made one this morning, I think. I don't know if I did or I dreamt it. I made one this morning, 11 months ago. No, I didn't. I dreamt it. Never mind. I'm going to make a new Git project. You don't have to do this. We actually create all of these for you in the course, but I'm just going to call this one lecture demo because it's a demo for the lecture. In the course, you can actually go and see all of the Git repos you have access to by just going to the homepage of GitLab. I see a lot because I'm an admin, but you'll just see yours. So if you, for instance, are Jasper Anderson, you'll see this on your homepage and you can click on that and go into your Git repository and it will look like this. Yeah. And we'll talk about that in a sec. So you all have your own Git repos. And the way it works is that in this course, you have a Git repo for every lab activity you do. So for week 1, there's 5 lab activities. So we've created 5 Git repos for you. You can actually find them by going to the tutorial and labs pages, going to lab here like we did earlier, and then clicking on Git basics. And what this will do is this will prompt you for your username and password. This is so we can find the right one for you. And once you type it in, this won't work for me because I'm not a student. Once you type it in, it will take you to the right place in GitLab. So for instance, if we're on someone else's ZID here, it'll work for you. In terms of our little demo today, though, I've got my own little Git repo here. Yours will, kind of look... Let me make a file first, because I just want it to look like what yours looks like. Yours will have some kind of, MD file in it. Justin says, we'll learn how to access GitLab at the labs. I don't think there's much to learn. It just asks you to log in, and you log in with your ZPass and Z number. Like, all the links are on WebCMS3. You just follow the links, and there's nothing to set up. The access is all just via WebCMS3. Art Smart says, why didn't we use one repo for all of the Lab 1 exercises? That's a good question. The reason we didn't use one repo is because of the little green ticks and red crosses you might have seen, which we'll also talk about sometime. And it's because those are easier to do with one lab, basically. It was a difficult decision, but we're happy with it. It's a little bit more overhead, but there are actually benefits. Mary says, is there a way to disable emails that Git sends when you're made a developer in the labs? Yeah. Well, I mean, firstly, they tend to come out in one big swoop, but I'm pretty sure you can just go to settings and change your notifications or something. I can't remember. Notifications. You can just turn them off. It's pretty easy to turn off. I just don't know if we can do that by default. So it's totally fine. Like, you got settings, like it's your own account. You can log in and change lots of stuff. You can change your name. You can add your Twitter handle. You can do things. Yeah. So what we've got now is we've got our Git repo. Git's being slow now. So I've got my Git repo, and it looks like this. Now this looks like a standard Git repo you might see on GitLab. When you want to work with it, the first thing you do is you clone it. And you clone it by clicking on the big blue clone button. You then copy the SSH clone, right? And you come to your terminal. In this case, I'm going to go on my VLab machine, and I'm going to go to my home directory. I'm going to make a folder. I'll call it labs, and then I'm going to go into call it anything you want. And then to clone it, I'm going to go git clone, and then I'm going to copy and paste this in here like that. And what this is doing is that, like, currently you have your, like, this is GitLab up here with your repo, the lecture demo repo. And what's happening is you're saying to Git, hey, I'd really like it if I could get a copy of that too. So what it does is it sends it down to you, and now you have a copy of that exact same, I'll call this VLab lecture demo, right? Super simple. So that's what the first step is. It's basically like taking what's on the GitLab server and creating a copy of it locally. When it creates a copy of it, though, it creates it in another directory. So you do have to cd into that directory to get access to it. And now you'll see the file there. So you see readme. If I cat readme to get the contents of the file, you can see it says hello, and that's actually what's on GitLab as well, right? That's what's actually sitting here. If I click on readme, it's actually just the file hello. So we've done our cloning. You do that once per repo. You can obviously delete it and reclone it too, anytime. I could just delete that folder and do it again. I would lose everything in that folder, but I would pull what is stored in the server at the time. Some other questions that have been followed up. So if anyone gets 404s with their GitLab, if you enrolled today, you're going to have to wait till tomorrow. You have to wait a day. If you didn't enroll today, then post on the forum and we'll help you out. That's pretty much it. And someone says, does our Git name and email need to be our name and student email? It does not need to be your name and student email, but it does need to be identifiably you. So like it should be a name that is clearly you and not your team member, and it should be an email that is clearly you and not your team member. That's what I would probably say. Okay, so we've cloned our repository from GitLab. We've got it right there ready to go. The next thing we're going to look at, and I just want to take another, I'll take another stop. Justin says, I'm still confused how we used GitLab via Tiger VNC. I think that question, what I don't want to conflate is this idea that GitLab via Tiger VNC is a thing. It's like, GitLab's a website. right? gitlab.cse.uns. Like, I can access that on my phone, I can access that on my computer, I can access that on VLab, I can access that a whole bunch of different ways. And all I'm doing is deciding to clone from a website, GitLab, to whatever machine I'm on, which might be VLab, it might be my local machine. In this particular case, I'm on VLab cloning it here. And I've got my repository. There are two commands that we can use to check on the status of our Git repo. One is git status, and what git status tells you is a whole bunch of things that don't mean a lot to you right now, but this is a command that will essentially tell you if you have work that is unsaved. That's the most common thing that matters to you right now. The other thing that's going to happen is there's another command called git log, and what git log does is it gives you a history, like a log of all the different things. So, for example, when you're on Google Docs or something, you can actually click on history, and you can do this in a lot of applications, and it kind of says, yep, this happened, and then this we saved 20 minutes later, and then 30 minutes later, and you can kind of go back through all those different points in history and see what the changes are. Git has a very similar thing, except it has what we call a log, and you can see here that there's just one thing that's happened, and it was the adding of the new file that I created just before. So we're going to add more things to this log by working on it, but for now there's just one thing on this git log. That's it, nothing else. So these two commands help you understand the status of your work. The status, I mean, that is a funny description. But we actually want to add things to Git. We actually want to do some work. So let's say you're doing your labs, right? Let's say this is a lab 1 repo, and you need to make a file, for instance, or you want to modify a file. Let's first try and modify readme.md. You don't have to modify this for your lab, but you can if you want. So what I'm going to do is I'm going to, firstly I'm going to modify the file. So I've cloned it, I'm ready to go. I'm going to modify readme.md. I'll open this up in gedit, love gedit, and then I'll say, hello, Justin, my favorite student. And then I'll save that file. And I can close it, I can leave it open, it doesn't really matter. Now what you'll see is that if I type in git status, that what Git's telling me now is that it has seen that since I've cloned it, there's actually been a change that I've made. It's aware that there's a change that I've made here to a file. And it's telling me, it says there's a change that's not staged for commit. Okay, well, what the hell does staged for commit mean? That's kind of a little bit, a little bit vague. And essentially, the way Git works is that you kind of have your repository, and when you make changes, once you're happy with those changes, what you do is you basically get them ready, and then you package them up into a little snapshot in time. And getting them ready to be packaged is what we call staging them, and committing it is what we call taking a snapshot. So changes not staged for commit essentially means changes have not been pre-packaged, ready to take a snapshot of your work as another item on the log. So to make that like a change, I can use git add. And what git add does is git add tells Git, hey, can you take this change that has not been staged, has not been packaged, and just get it ready to take a snapshot. So if I do git add and then the file name here like this, and then I do git status again, you'll notice the change in the color and the words. It says changes to be committed, which means changes ready for a snapshot to be taken of that change, right? And with that particular, adding, we're now ready to do a commit. And remember, a commit is a snapshot of time. It's like these what do you call them? Keyframes in history or something like this. So I can commit these changes by saying git commit. Git commit is the command to say I want to create a snapshot, go save right here, add it to the log. This is a particular point in time that matters to me. Except when I commit, I need to give that commit a particular message, because every commit has a different message. In fact, we saw one up here. This commit's message was add new file. This is what GitLab did for us, but here I can add my own message calling, I'd say adding Justin info or something. Something meaningful that tells people what you've done. You can put a space between the -m and the there can be a space there or not, it doesn't really matter. When I commit that, let's see what happens when I do git status again. Git status says what it said earlier, which is that there's nothing to do, right? It's like nothing to commit. It's basically like there are no changes. And it's like, what do you mean there are no changes? I just made a change. I just made a change where I added Justin. But if we look at the other status command, which is git log, you'll see now that there's 2 items on the log instead. So the first item is the add new file, and then we have adding Justin info. And you know what? Let's modify that further. I want to add someone else to that. Who's the lucky person? Riley. I also think Riley is okay. Sorry, I think I'm funny. So we have another change here. And then if I go git status, you'll see the same thing. It says, I see you've made a change, except it has not been packaged for the snapshot. It has not been staged for the commit. So I want to stage it again. But while we're here, I want to show you a really useful command as well, which is git diff. And what git diff does is it gives you a little summary of the changes that have been made on terminal. So if I do git diff, it actually tells me since the last commit or since the last snapshot, what's happened is that you've added a line here. So it shows me the differential between the work I've got so far and the work from the very last commit that was made. That one's really useful if you want to get like a quick sense of like, what the hell did I do again? Because like that's a problem sometimes. You're like, what did I change? I don't remember what I changed. So this helps out with that, though most people won't use that. I think it's super useful. So I've got that. I git status because I forgot what's happening. What are we doing again? Oh yeah, I modified this file. It's not ready to be committed. If I try and commit now, say adding Riley, it'll say to me, no changes added to commit. It's like there is nothing packaged for the snapshot. There's nothing staged for the commit. So I have to add that again. Git add readme. Okay, git status, now it's green. So now I can commit it. Git commit adding Riley. And now I've committed it. When I git status, it says there's no changes. Because git status shows me what's changed since the last commit that I made. And when I do git log now, you'll see that there's actually 3 different kind of commits. Right, 1, 2, 3. And these are all snapshots. So what commits are, again, I've referred to them as snapshots in time. There's a lot of theory behind what all of this stuff is, but essentially they are just literal snapshots that you can, if you need to in the past, go back to. And it also gives you a sense of like what has happened, so you can kind of track what has happened. What I also want to point out is if you have a look here, you'll see that on GitLab, nothing has changed. It's still the same file. And in fact, when I go to commits, you'll see that there's only 1 item in the log, which is the add new file like commit. There aren't any more than that. And the reason for that is because we said before, Git is a distributed version control software, which means every single person using it has their own copy of it. So what's happened here is that I've cloned the Git repository from the cloud to my local machine, but I have yet to sync it back up, because Git isn't just constantly syncing stuff all the time. It's not like Dropbox that's just sitting there in the background, like, you know, like just trying to shove things up in the cloud all the time. It's waiting for you to tell it that I'm ready for you to sync back up to the cloud. So the last command that we're interested in here before we go through some questions is git push. And what git push does is it says, okay, I've got all my local stuff here. I want to go and push those commits up to the cloud. I think the big misconception that happens is that students think that git push says, I want to push my code to the cloud, but you're not actually pushing your code. You're actually pushing the commit history, which includes your code. So like, while you can easily think of it as pushing my code, like, and that's what people say because it makes sense, what's actually happening is that you've got this commit history, which is a series of snapshots that have certain information in it, and you're saying, I want to just make that the same on GitLab so that it has the same info as me. So if I do git push, what happens? It will push it up to the cloud. Now, depending on how you set up Git, and I'm aware my own VLab is set up slightly differently, so there's some subtle things. Sometimes you might want to do git push origin master. This will get around a few problems that can come up. basically, what git push origin master does is it says, I want to push to origin, which is GitLab. Origin is where you cloned from. It's always origin. And then you want to do master, which is the branch you're on. Branching we talk about next week. But basically with Git, it's not just a version control tool, but you can actually have like different kind of copies or different, you know, when you like work on something, like maybe you have some code and you think, I'm going to do something that might break this. So I'm going to copy and paste my file and I'm going to work on the second one. And if it's all terrible, I'll just delete it. And if I like it, I'll delete the first one. You know, like that's effectively what branching is. And we talk about that next week. But for the moment, we're just focused on like a single kind of thread of work, which is what is always by default called the master branch. So this also would push it. When I run this command again, nothing happens because I've already pushed it. So it's just like, hey, this first one says, okay, I'm talking to GitLab. I will give it all of your commits and update it for you. The second time, it's like, I already did that. What do you want from me? Everything looks fine. And if we go back to GitLab now, and I refresh this page, you'll actually see that the commits are here as well. It's the same information. In VLab, I'm just accessing it via command line. On this side here, I'm accessing it via the GitLab interface. So these are all just snapshots of work. Okay. Few questions here. What's the practical purpose of separating the commit and add commands? You don't always want to commit everything you change all the time. Sometimes you might be working on 10 files, but you're only interested in committing a few of them. So it's just an easy way to separate things. Liu says, Matthew Liu, not sure, says slightly unrelated, but how does the system know if we are git adding to GitHub or GitLab? Well, there's no real difference. Like a Git repo is just a repo, right? Like when you save a Word document on your computer, it doesn't care about whether it's, you know, going to Dropbox or OneDrive or Google Drive. It's just saving it. So, you know, all of that stuff, it's just storing it in the Git repository. There's a few questions which will be answered on Monday, so I'm not going to touch them too much at the moment because they're not urgent. Jesse says, wouldn't this break code if multiple people were accessing it? You'd have multiple versions of code at a time. That's an excellent question. So one of the benefits of Git is that it is very comfortable, which again we talk about on Monday. It is very comfortable with having multiple people committing different files at the same time, and like, you know, Git will just figure it out. We'll go through these processes of like making them all mesh together. In fact, Git is very comfortable as well with you both editing different lines of the same file. If you edit a line up the top and someone else edits a line at the bottom, Git will happily figure out how to shove them all together. Occasionally though, Git will not be able to do that. If you both edit the same line of code and you both try and push it, Git will need you to manually figure out what the hell is going on. And that's what we talk about next week. Aaron says, how do we revert things? How do we unwind changes? That's actually something that we're not going to talk about till the end of the course because it's not good practice. But generally speaking, if you make a mistake right now, what you do is you actually should make another commit. So for instance, let's say I shouldn't have added Riley. I will go and remove Riley. I will git status. I will add the readme. I will git commit, removing Riley. I will git log to see what's happened. I've got 4 commits now. And then I will git push to GitLab, and that's how you revert things for now. We'll do the formal way later in the course, but it's a bit complicated, requires some more assumed knowledge, and generally speaking, you don't need it because you can just change things like this. Okay. Is there a way to tell which commit was done on which branch? Yes, but we'll talk more about branching on Monday. So Jesse says, so with the commits, it's more like what changes to the code you've made rather than pushing the actual code to the cloud. I really don't want to get too deep into the Git theory, but what Git is basically a series of changes that are stacked on top of each other. So the way Git actually, like when you go to GitLab and you look at this and it says this is the file, what it actually kind of does, the way to think about it, is it actually goes through all the commits and kind of like generates the file for you. So it like applies all these commits and stacks them on top, and you get the final result. So Git is a change tracking tool, but if you figure out all the changes, you know what the end result is. So that's how it knows what the files are, because it kind of sees all the changes. Oh, Monday. Sorry, I keep saying Monday. I mean next week. I'm terrible with this. I will say things sometimes, like I'll say I'll see you on Tuesday. I just mean our first lecture next week. If I ever say Monday, I just mean Wednesday. I just mean our first lecture. I think last time I had a lecture on Monday for 1531, so my brain always takes a week or two to wire in the days. Sorry about that, everyone. Cool. Lots of questions. Any question I'm not answering is because we're going to go through it on Monday, and you don't need to know it right now. You'll be okay. Did I say Monday again? We're going to go through it next week in some more detail. Great. While your project is released on Friday, which means you might want to do some teamwork stuff soonish, it's like realistically, there's enough playing around and enough like figuring things out between, like, okay, how to put it. Between settling into the course and stuff, we don't actually expect most teams to start the project till next Wednesday anyway, because like you're going to be doing the first labs, you're going to be getting settled. By the time you submit it, it's going to be Monday, and then we have a lecture, 40 hours later where we can go through some of this stuff in a little bit more detail. Okay. So we've done these kinds of commands. One kind of thing to get at here is just to understand how Git is distributed. This next topic, which is around multiple of your own machines. This isn't something that's that common, right? Like most of the time you're either going to be working by yourself on one machine or you're going to be working with other people. Though sometimes you'll work on two machines. Most of you won't though. But the reason we talk about this is because it's a nice little segue to working with other people. It helps you understand a little bit more about Git and merge conflicts and stuff without having to get too caught up, on the specifics of like how to deal with branches and everything right now. So super easy. What we're going to do here is that I've got my lecture demo repo here. It's got all the commits. It's totally in sync with GitLab, right? Because GitLab's here. And what I'm going to do now is I'm going to clone it on my local machine. So my local machine here is like, see my little terminal? This is like my own computer, Hayden at desktop. So I'm going to clone this, and I'm going to do what we did before, where I'm going to write. I copied and pasted this from the blue box, and I'm going to go git clone that, and then it will clone it, and then I will cd into it. And what you'll see here is if I git log, I've got the same files because I just pulled it from GitLab. So I just got the latest changes. Now, what I want to show you next is like, let's see what happens if you edit it yourself, or I mean, in theory, this could be another person, of course. The reason I say working by yourself is because if you're working with other people, you should always be working on different branches. But that's, again, not for today. So let's say on my local machine, I want to make a change. Maybe my change will be that I'd like to add a file. That file might be called, hi.py. And we're going to be talking about Python tomorrow. But this is a really simple Python program. Print hello world. That would just print hello world to the terminal. We'll talk more about Python tomorrow. When I go git status, you'll see a slightly different message here, which is untracked files. This is different to what we got before. And that's because what Git has is a list of files it's tracking and a list of files it's not tracking. And if we want to if this is a new file that Git has not committed before, we kind of have to tell Git we want you to track it. Thankfully, to track a file, we do the exact same thing we normally do. We just go git add and then the file. And then when I git status, it's now green again. It's now ready to be committed. Easy. So now I can commit this and say adding hello world file. Sorry, sometimes I move my head around because the camera's actually I have my window right behind the camera. So I've got that, and when I git log now, you'll see that I might make this a bit bigger. You'll see that I've got 5 commits now. So I've got the 4 previously from the Hayden on VLab, and now I've added a 5th commit myself from the Hayden on his local machine, and when I go back to my GitLab, you'll see there's still only 4 commits because I haven't pushed this. I haven't synced this up with GitLab yet. So I git status, and I see that, I've made the commit. And in fact, git status actually tells you, it says your work is ahead of origin master by 1, your branch is ahead of origin master by 1 commit. This is a little bit cryptic, but what it's saying is your work is ahead of GitLab by 1 commit. It's like you've done some stuff that GitLab doesn't know about. So I'm going to git push now. And it will push itself up to GitLab. And when I go to GitLab and I refresh the commits, you'll see that I have the commit there. You can tell because it's the different little icon or whatever. And when you go to the lecture demo, you'll now see that there are 2 files, because there's the removing Riley, which we modified 6 minutes ago, and then there is now the hi.py, which I just added. So let's imagine we're working on 2 different machines now. The problem is that the person on VLab, Hayden number 1, Hayden VLab, when I look at my git log, I've still only got 4 commits here. Okay, well, how do I get the rest of the commits? Well, the easy, stupid way would be I could delete everything and reclone it, right? I could just totally reclone it and I get everything because I'd be starting from scratch. But the better way is the opposite of the git push command is the git pull command. So if I do git pull, what will happen now is that we will be pulling from GitLab to our machine, and we're syncing the commits from GitLab to our local now. So it's the other way around. So git pull, it'll say we've got, new commits. It actually tells you in the detail, hi.py has been added. It was a 1-line file. There was 1 file changed. And when I go git log, you can see that there's now 5 commits. And when I do ls, you can see that there's now 2 files. So you can see that this is kind of the to and fro of how one person can work on something, or you in 2 different positions can work on something, push it up, someone else can pull it down, etc. This works seamlessly without any problems if you kind of do all that work separately, where one of you starts some work, does some work, pushes some work, and the other person pulls some work, does some work, pushes some work, right? Where it's all mutually exclusive. But what I want to show you is if you both try and modify 2 different files at the same time. We can have a quick look at that. Isha, your question about git fetching, I don't know if I call it good practice. It's more tools, and sometimes it's good to do if you're not sure what you're doing. I use it sometimes. Tiara has a great question. If we ever work with other repo sites like GitHub or Bitbucket, are the commands the same? Yes, they're exactly the same, because Git is just a language. It just so happens that there's 3 different big companies that, there's more, no doubt. There's 3 big main companies that just implement a website for you to interact with, but it's all the same commands. Git, Git. You can go and use GitHub, whatever. The only thing that changes is the web GUI. The only thing that changes is like the actual website you interact with, which can be quite different. Okay, so what I want to do now is we've got 10 minutes left. Let's say I'm going to modify a file on VLab as Hayden VLab, and then I'm going to modify a file on local as Hayden local. Or you could imagine that it's 2 different people. So on Hayden VLab, I'll go and edit README, and I'll add a new line here, which is that Tiara asks good questions. Great. And now what I'm going to do is I'm going to git add that, and I'm going to git commit that. Before you git commit and stuff, I'd always recommend doing git status. It'll make sure you're like doing the right thing, because sometimes you'll forget what you're committing. Adding important note on Tiara. Great. Cool. And let's say before I push, I'm going to go over here, and on my local, I'm going to modify my hi.py and change hello world to hello Isha. Isha, sorry if I don't pronounce your name correctly. Similar thing, git status, git add hi.py, git status, good, git commit -m, changing world to wadul, changing world to Tiara, git status, good, nothing to commit, I'm ahead by 1, and now we're in the same spot between VLab and my local. So here's the interesting thing about the way Git works. The first person to push to GitLab on the same branch, this is all on the same branch. So the first person to push to GitLab here will have their stuff get pushed easily, and the second person will have problems that are quite quickly resolvable. So I'll try this on VLab first. So I'll say git push. Now VLab, because you know, nothing has changed since GitLab. Since VLab's push, you'll see that it got its push in totally fine. I can go to commits and I will see here that we have that commit. Now watch what happens when I try and push this change here. First, you know, git push like this. It's going to complain. It's going to be like, no. And what it's complaining about, this is important to understand, is that the way Git likes to work is that when you push your code up, it likes it, like your commits, it likes it to be like logical in the next order. So what I mean by that is that what kind of happened here was that you had, you know, like these 5 commits like this. You know, and this is what's on GitLab. And then on VLab over here, we had like, you know, our commits, and then I'll have like local over here. And what happened was that on our VLab, we made a commit, and on local, we made another commit. I'm just going to use different colors so we can understand that they were different commits. Like this, there's our local commit, and then we did this one on, oh, there's our VLab commit, and then we did this one on local. What happened is when we set on our VLab push to GitLab, what it does is it looks at its history and it says, GitLab is just exactly what I have, but longer. It just has more commits. So it very comfortably, very easily just adds that commit here. When we then are on our local branch, which has this different color here, and we say push to GitLab, sorry, what happens is it tries to push, but it's like I can't, like, I had this black one and then I had a blue one. I don't know anything about this. I don't know what's happened here. Something has changed since I last saw you, GitLab, and I don't know what to do. So your local Git craps itself and it says this, and it says blah, blah, blah. Changes were rejected because the remote GitLab contains work you do not have locally. This is usually caused by another repository pushing to the same thing. You may want to first integrate the remote changes with a git pull. So this is how you solve this problem. If you run into this problem, you simply do git pull, because Git is capable, right? Git is very capable of combining these things, but it doesn't like to do it on a push. It likes to do it on a pull, right? So it doesn't like to push conflicting stuff up to GitLab for it to sort itself out. It says, no, you pull from GitLab, you sort it all out locally, and then you push the update to me. So what happens is I do a git pull here, and what a git pull will do is it will try and pull this orange one to my local work. And you will see it will bring up this little thing here where it says merge branch something, something, something. This is a piece of text that you can just close. In this case, it's nano, so I can just close it. And now let's have a look at the git log. When I look at the git log here, what you'll see is that I have my add new file, Justin Riley add hello world, right? I have all those commits, but if we go back to GitLab, you see I have my add hello world that I added locally, and then there's the important note on Tiara, which was added by VLab, and then there's my note here, which was the changing world to Tiara. That's the one I was trying to push that it wouldn't let me. And then I have this weird commit here called merge branch master or whatever. And what this extra commit is, it's a bit of magic that you don't need to overthink at the moment. But this is GitLab shoving it all together. This is Git, doing its thing. Its thing of like just being like, oh, you've got to change and you've got to change. Let's just shove them together so that we have like a common history. And what you'll see now is that if I try and push this to GitLab, it will push the change I made now. And I'll also get this annoying little merge commit. So this was the change on VLab. This was the change locally that I couldn't push, wouldn't let me. So I had to pull, and then it did some magic, and then it would let me push now. And this is this weird auto-generated commit that just made it all happen together. Now, in our last couple of minutes, and I'm going to try and rush through this one, let's have a quick look at what happens when you both work on the same code on the same branch. Now, this shouldn't happen generally if you're like doing things properly with a team. Let's say that, let's make sure that my VLab has the latest changes too, git pull, because it's got to get the latest changes from GitLab, right? Okay, now we're both going to modify hi.py, and I'm going to be quick about this. I'm going to change this one from Isha to Vandana, and I'm going to commit that, git commit, git push like this. Great, and then I'm going to do the same thing on this one. I'm going to modify hi.py, and I'll change this one to Hayden, and then I will git add hi.py, git commit Hayden, and then git push. I get a error here, right? Because one is already pushed to GitLab. So again, I need to do a pull. This is exactly like it was before, except when I do a pull, Git pulls it, but it's like, holy hell, I don't know what happened here. I don't know how to just magically solve this. This isn't two different files or two different parts of a file. You have literally changed the same line of code, friend. Help me out. And what Git wants you to do here is it wants you to open that file, and it wants you to, like, whatever the, the word the more gender-friendly version of manhandle, right? Like, it wants you to just, like, grab the stuff and just shove it in the right place. There's nothing pretty about this. There's nothing elegant about it. You literally just have to look at this, maybe call up the person you're working with, or if it's just you in this case, then you're like, oh, I didn't mean to do that. So maybe you just go and, like, update this to be both. This can be anything, but you get rid of all the crap here. You just, quite literally, heavy-hand it. Thank you. That's what I was looking for. You just force it into place. There's no, that's what you do. And then you save it, and then you git status, and then you add it like normal, and then you git commit it, resolving conflict, whatever you want to call it, and then you just push it, and then it will go to GitLab, and everything will be fine. That's how you deal with what we call merge conflicts. It's very similar to the other stuff, and again, if you're lost, you can always watch through this again. You can always click through it again. We're going to see this more often. We're going to be talking about this again. This is just an intro so that you feel like you have enough of a grip to get started. Which is good. And then Lorenzo said, what does the last commit on GitLab look like? It looks like this. So here's the Vandana commit, here's my commit, and then this one is, again, this is like the magic commit. Basically, every time you have to do a merge between divergent stuff, there is not every time. Usually there's a commit that has to be done to bring it back together. Sometimes Git can automatically make that magic happen for you. Sometimes you have to make it happen. That's the main difference between it here. I'm going to pull up the feedback just because we're in our last... Oh, here's I wrote this Git summary if you want to look at some basic commands here. There's some I didn't touch today, but again, this is going to come up every week, so we'll just keep talking about this. Just to answer some final questions here. We're going to talk about branches next Wednesday. I don't want to give the impression that you need to wait till next Wednesday to actually start the project, though, because the labs, the project specification actually give you really clear instructions about how to do basic branching and basic work. So many people will not get much done between now and next Wednesday because the project comes out on the weekend. You're still going to be finding your groups. You're busy. It's the start of term. No one cares about uni, right? But if you do need to start before then, it's really well signposted in the spec. It's really well demonstrated in the labs. Super simple like that. This is taught in detail in the labs. Everything today is just to give you a practical hands-on. There is extremely good detailed instructions for all of this kind of stuff. If I've missed a particular question, please feel free to ask me tomorrow, though, and please fill in the feedback too, just while I'm talking. The only kind of couple of quick notes I'll say are that on your labs, you will typically find that there is a little green tick sometimes up here. Maybe not for that one. There's a little red cross or green tick. This is essentially kind of the equivalent of auto test for the lab. We're gonna again talk more about this, and there's gonna be a project pre-video that I release where we talk about the project, where I will talk about that green tick and stuff. So that'll come out on Friday night. But in the meantime, that's kind of the equivalent of an auto test. It just kind of runs in the background for GitLab for you. Is it inappropriate to hit on your tutor? Yes, don't do that to the poor souls that that would have to be on the receiving end of that. Caleb says, any tips on writing good commits? Not really. Just make just describe what happened in a sentence is usually best. You can't over detail commits. That's the short answer. The rest of the questions, I think I will answer later. We're going to wrap up now in the next 60 seconds because people have things to do with their life. Just a last comment. Remember, you'll find tomorrow's lecture up on the lectures page like normal. For your tutes and labs this week, your Zoom links are sitting right here on the tutes page. Go and join it. Your tutor and your lab assist will be super helpful this week. And if you want to see the tutorial lab content, go here. Other than that, I'll see everyone tomorrow and we'll keep chatting about Python tomorrow. Tomorrow's a lot about Python. This week's all really just about getting you ready to start the project. And we'll do all the Python and testing stuff tomorrow. And if you have any other issues, post on the forum and we'll help you out. So thank you, everyone. Have a great day, and we'll see you soon.